Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy and we are continuing our video series today on surds by looking at how to rationalise the denominator. Now, if you haven't watched our previous videos on how to simplify and also do multiple operations with surds, I recommend you watch those first before you start this, because we are stepping up the complexity today. Now, if you'd like to know how to engage further with us here at McClutchy Maths, here's just a few ways you can go about that. Firstly, you could like and subscribe and hit the notifications bell so you'll always know when the next video is available to watch. You could tell somebody about this video. Why not consider sharing it on your Class 1 or hitting the arrow button to send that to somebody via email or a link. Why not follow us on social media? We're on Facebook and Instagram. It's a great place to stay in touch. And also you could consider hitting that little love heart button, super thanks, where you can donate $2 to keep the running costs of the channel so that we can keep producing these wonderful videos for you. Hopefully you find them wonderful. Okay, let's talk about what rationalising the denominator means. It's a term you might not be familiar with. Well, remember, we've talked about rational numbers. A rational number is a number that can be converted into a fraction. So when we talk about rationalising a denominator, the denominator, which is the number on the bottom of a fraction, so we're talking about surds here that are fractions, the part that makes up the denominator needs to be turned into a rational number. So sometimes you might have that denominator in a surd form, and we're going to be talking about how to transform and make an equivalent fraction so that we've now got a whole number on the denominator instead of a surd. Okay, so that's what we're talking about here. The denominator is no longer a surd, it's a whole number. So to achieve this, the way we go about it is to multiply the fraction by the number 1. Now, anytime we multiply anything by 1, we get the original result. But we're going to be doing that in the form of the denominator over the denominator. Now, anytime we want to transform a fraction, we can times it by number 1 in a different form. So if I wanted to make an equivalent fraction of a half, I could multiply that by 10 over 10. 10 over 10, or 10 divided by 10, is simply 1. If I multiply a half by 10 over 10, I'm now going to get an equivalent fraction of 10/20. And that's the same principle we're following here. We're just going to multiply that denominator by a surd, that denominator, which is a surd already, take that surd and transform it into a fraction over itself. So let's have a look at what that looks like. So I've got this first one here where I've got to rationalise this denominator of root 2. So what I'm going to be doing is taking this denominator and multiplying it by 1 in the form of root 2 over root 2, because anything divided by itself equals 1. Now, what this is going to do is, remember, when our rules for fractions is we multiply the tops, we multiply the bottoms, and then we simplify vertically. Now, when we do this, we've got a surd multiplied by itself, and that's the equivalent of squaring the surd. We know that squaring cancels out the root sign, so we're going to end up with just 2 on the denominator. And obviously the tops are now, or the numerators, they multiplied together, 5 root 2 over 2. If I could simplify this fraction anyway, I'd definitely simplify that at the end, but this is as simple as it goes. Okay, so that's our principle as we start to step up the complexity, is that we are multiplying this original fraction. We've now got an equivalent fraction with a rational or whole number denominator. Let's look at another example here. 3 root 5 over root 3. So now this time what I'm doing is I take the denominator, turn it into a fraction equivalent to 1, root 3 over root 3. So now what I'm going to do is have this multiplied, and then this will be multiplied as my new denominator. So my new denominator is going to be root 3 times root 3, or root 3 squared. Square will cancel out the square root, so I'll end up with a denominator of 3. Now, you need to watch our video number 3 on how to multiply surds, because when we multiply surds, we simply take the numbers under the square root signs and we combine them as a single multiplication under one big square root sign. So now I'm going to have root 5 times root 3 becomes root 15. Now you'll see here I've got some cancelling going out, because this 3 becomes a 3 root 15, and this becomes the whole number 3. Now I've got 3 divided by 3, which is 1, so this is simply going to be root 15. And I could write that as a fraction, root 15 over 1, but remember, anything that's divided by 1 is just itself. So we just write root 15. It's technically now got a rational denominator. Let's look at our third worked example. This time we've got coefficients out the front of our surds on the numerator and the denominator. 2 root 7 divided by 9 root 6. We're going to multiply that by root 6 over root 6. Same principle as before. Now what's going to happen here is on the numerator, I'm going to combine those two surds under the square root sign, as we talked about from our third video, and root 6 times root 6 becomes simply 6, and now I've got root 9 times 6 on my denominator. So now if I take this a little step further, 7 sixes are 42, 9 sixes are 54. I've now got 2 root 42 over 54. Now here's where I need to put my thinking cap on. Firstly, I need to think about this number 42. Can I actually simplify that surd at all? And I've also got on the outside 2 divided by 54, or 2 54ths, and I can simplify that fraction for sure. 2 is the common factor for both of those. So let's cancel that out, and I've got over 27. Now if I think about the factors of 42, it could be made up of 21 times 2, and that's about it. 21 is not a perfect square, and neither is 2. So I can't actually divide anything else into that and get a nice even result. So no, I can't simplify that. That is just a surd on its own. Okay, worked example 4. Now I've got some addition and subtraction in my fractions. Once again, getting a little trickier. So at this point here, no coefficients to worry about on the numerator or the denominator. So that's good. I've got root 3 take away root 5, all divided by root 2. Now I'm going to multiply this once again by root 2 on root 2. And because I've got these two terms, when I multiply the numerators, I need to put this in brackets because I'm going to be doing 2 lots of multiplication here. So I'm going to put root 2 outside the brackets of root 3 take away root 5, and the denominator simply becomes 2 because root 2 times root 2 is just 2. Now I need to use my expanding of single brackets. This term will be multiplied by this term will be multiplied by that term. So root 2 times root 3 becomes root 6, root 2 times negative root 5 becomes root 10, all over 2. Now these are both in their simplest form. I cannot simplify them further by bringing one of those perfect squares out the front. So there's nothing I can cancel out with this 2. Now you might think, well, maybe I could do that divided by 2, that divided by 2, that divided by 2. Well, no, it's not 6 divided by 2, and it's not 10 divided by 2. It's root 6 and root 10 divided by 2. Here's our 5th example today, and that complexity has stepped up once again. I've now got 2 fractions with different denominators, and I need to subtract them from one another. Now I know from fraction rules from primary school that to subtract fractions that have different denominators, I need to first make a common denominator. But what we'll do first is we'll try rationalising this denominator first so that it's a lot simpler for us to work with, because we're used to working with fractions with rational denominators. So let's rationalise these one by one, which means I'm going to multiply the first fraction by root 3 on 3 and the second fraction by root 2 on 2. So then we'll deal with those denominators being different later on. Okay, so what I'll end up here is with 3 root 5 and 2 root 2 on the top there. Down the bottom here, this will become a 3, because root 3 times root 3 makes 3, times 2 makes 6. Okay, so this is my first fraction here, 5 root 3 over 6. Take away this next part here, 2 root 2 over 3 times 2, because root 2 times root 2 makes 2. So interestingly enough, this has worked out that we are going to have the same denominator. So that will make life really easy. So I've got now 5 root 3, take away 2 root 2, all over 6. I could have left those as separate 6's, doesn't matter. It brings the 2 fractions together. And these are now 2 different surds. Don't be tempted to take them away from one another. They are not like surds. One's a root 3, one's a root 2. So I actually cannot simplify this any further. I've done my job. So I could have left this as 5 root 3 over 6, take away 2 root 2 over 6, but the most simplest form is to bring it together in one big fraction. Well, I hope you found this video helpful today. If you've got any questions or you would like some more complex questions like the last one that you saw, you can reach me on mcclutchymaths@yahoo.com. Well, you've been watching McClutchy Maths. I'm Natalie McClutchy. Have an amazing day.